Hi again. So today we are going to discuss some important problems which are related to the probability and random processes for electrical engineering second edition. So the first problem here is basically the 32nd problem, and what is it asking us to find the combination to a log is given by three numbers from the set 0 to 59. Find the number of combination possible. So here we can very easily see that there are basically three, we have to pick the three numbers and we have to see that how many combinations are possible if we pick three numbers from these 60 numbers. Okay, so again let us suppose we have here three spaces, and in each of these three spaces how many possible choices do I have? So in the first space I have 60 choices. Okay, in the second space how many choices do I have now? Because repetition is allowed and it is the sampling with replacement, so now again I have 60 and at the end I have again 60. So these are the three spaces, and here the number of choices will be 60 multiplied by 60 multiplied by 60, and that is basically the 60 raised power 3. So the number of possible combinations are basically 60 raised power 3. So these are the number of possible combinations. Okay, so that is the answer. Similarly, in another problem, it is asking us to find the number of possible outcomes for a six-sided dice tossed, a coin is flipped, and a card is selected at random from a deck of 52 distinct cards. Okay, so we have to find the number of possible outcomes. So here we can very easily see that this is basically the AND problem, in which the die is tossed and a coin is flipped and a card is selected and random from the 52 distinct cards. Okay, so this is the AND problem, and for all the AND problems I basically use the multiplication here. So for the six possible outcomes here, similarly the two possible outcomes for the coin toss here and the 52 possible cards here, this is the outcome. These are the possible numbers of outcomes. So the answer here will be 624. Okay, so the 624 number of possible outcomes are available here. But what is basically the concept here? The concept here is basically the multiplication rule, that what are the situations where I can use the multiplication. Similarly, if there was the OR situation here, if there would have been the OR situation here, I would have used the addition sum here instead of this multiplication sign. Okay, so now the basic concept here is to see the applicability of multiplication and addition here. Okay, similarly in problem 34, a student has 4 pair of shoes and never wears the same on 2 consecutive days. In how many ways can he wear shoes in 5 days? Okay, so basically he has 4 pair of shoes, 4 pairs he has, and let me write those pairs like 1, 2, 3 and 4. Okay, these are the pair of shoes he has to wear, but in 5 days he doesn't repeat the pair in the consecutive days. Okay, so let me again use the same concept which I have used for the problem 32. So writing the number of days here like 1, 2, 3, 4 and 5. Okay, so in the first day how many choices do he have? He have the full choices and he will have these 4 choices. Okay, the 4 choices out of 4, he has to pick one of the pair of shoes which he has to wear on that day. Similarly, after it, the day after it, he will not use the same pair of shoes he has worn in the previous day. So therefore the number of choices he would have would be 3. Similarly, on the other day he again can use the pair of shoes which he worn on the day before a day, but he cannot wear shoes now which he has day before it. So therefore again 3 choices. Similarly here and here is as well. So as you can see that this is again the combinatorial problem. So I will use 4 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. So that would be 3 raised power 4. I will have here 4 multiplied by 81. So that would be 324. Okay. So he would have 324 choices, out of which he can use any one in the 5 days week. Okay, so that is the solution of this problem. In problem number 35, he is asking us to find the 7 digital telephone numbers are possible if the first number is not allowed to be 0 or 1. Okay, so we have to find the possible number of 7 digit telephone numbers in which 0 or 1 is not allowed in the first place. Okay, so again I can use the same concept. This box type concept is a very useful thing which will enable you to solve the very complex problems. So grasping the conceptual overview of this is very important for you. So again, now dividing into the 7 possible slots, 1 2 3 4 5 6 and 7, 1 2 3 4 5 6 7. Okay, so now initially in the first place, actually how many numbers do I have? I will have 0 to 9, 10 numbers or 10 digits here, but initially in the first place he will not include 0 or 1 here. So 2 will be left here, so I will have 8 choices here. 8. How many choices do I have in the second place? 10. In the third place again 10, 4th place 10, and 10 here, 10 here, and 10 here. Okay, so again this is a combinatorial problem. So 8 multiplied by 10 raised power 6 basically is the answer here. Okay, so that is the solution of this problem, in which the allowed number of the telephone numbers will be 8 into 10 raised power 6. So this is again one of the combinatorial problem. Let's move on. Okay, so in question 36, ordering a deluxe pizza means you have 4 choices from 15 available toppings. So the available toppings are 15, and out of these 15 you have 4 choices. How many combinations are possible if toppings can be repeated, if cannot be repeated? If the number of toppings can be repeated or if cannot be repeated. So let us first solve the problem where toppings can be repeated. Okay, so if the toppings can be repeated, so how many choices of the toppings do I have? Again I have 4 choices here, so 4 slots here. So in the first slot how many choices do I have? Again 15. In the second again 15, 15, and at the end again 15. So how many possible choices do I have, or combinations do I have? Those would be the 15 multiplied by 15 multiplied by 15 and multiplied by 15. So it would be the 15 10 raised power 4. Okay, so these are the total number of choices if the toppings can be repeated. Similarly, the second part of this, in which it is asking us that the toppings cannot be repeated, so no repetition is allowed. No repetition is allowed. So again using the same diagram or the same slot concept here. So 1 2 3 and 4. So initially in the first place, how many choices would I have? I will have 15 choices, then I will have 14 choices, then 13, and then at the end I will have the 12 choices. Okay, so here how many numbers can I have? I will have 15 multiplied by 14 multiplied by 13 multiplied by 12. Okay, so getting the product here, I will get the answer, or from it I can also use the concept of the permutation, in which I have to use the NPR, where the N is 5 and R is 4, and from it I will get the, let me write it here, I will get the 15 factorial divided by 15 minus 4, or factorial, and from it I will again get the same combination or the same number here. So that is the solution where the toppings cannot be repeated. Okay, so that is the solution of problem 36. In 37, I have to find that in how many ways 10 students can occupy 10 desks, and similarly the same number of students can occupy 12 desks. Okay, so let me repeat it for the 10 desks. Using it for the 10 desks, again I can see that I will have 10 slots, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are basically the 10 desks. So initially for the first seat I will have 10 choices, and for the second I will have 9, then 8, 7, 6, 5, 4, 3, 2, 1. Okay, so these are basically the choices that initially for the first seat I will have total 10 number of students, and any one of those 10 students can occupy this seat. Similarly, when one of the 10 students will occupy this seat, now 9 students are remaining, and one of those 9 students will occupy the second seat here. Similarly, when out of 9, one of the students will occupy the second seat, again the number of choices I will have 8, then 7, and repeatedly one of those choices will be decreased, and at the end I will get one student which will have the only choice is to occupy the last seat which he has. Okay, so this is basically the problem, and this is the 10 factorial here, that 10 students have to occupy the 10 seats. Okay, similarly in B, where 10 students has to occupy the 10 desks. So this is basically the permutation problem, in which the number of desks are basically 12 and R is here 10. So NPR is basically NPR is 12P10. So 12 factorial divided by 12 minus 10 factorial, or 12 factorial divided by 2 factorial. So these are the number of choices that these number of students can occupy the 12 desks in my question. Okay, so that is the solution of the question number 37. In 38, it is asking us that a toddler pulls 3 volumes of an encyclopedia from his shelf, and after being scolded, place them back in a random order. Okay, what is the probability that the books are in the correct order? So initially the books were in some order. A toddler pulls them out, and then after another person scolded him, he puts it back, and we have to find that what is the chance that when he put back those encyclopedia, those were in the correct order. Okay, so again let me use the same diagram here. Okay, so here how many possible choices will he have to put the encyclopedia in the shelf? So initially how many books for the first slot he has? He will have 3 choices. For the second slot he will have 2 choices, and for the last one he has 1. Okay, so by seeing it I can very easily see that is a combinatorial problem. So 3 multiplied by 2 multiplied by 1, this is 6, and also this is basically the 3 factorial problem. So he has 6 number of choices in which he can put those encyclopedia, or 6 number of orders are basically the number of the orders of the 3 encyclopedia books which he can put on the shelf. Okay, so out of these 6, just 1 order is the correct one, so therefore the probability of it will be 1 over 6. So this is the probability that a person will put back the encyclopedia in the correct order. Okay, so that is the answer of my question 38. Now in 39 problem, what is it asking us? A deck of cards contain 10 red cards numbered 1 to 10 and 10 black cards numbered 1 to 10 as well. how many ways are there of arranging the 20 cards in a row? This is the first question, and let me solve it first. So as he has 10 red cards and 10 black cards, okay, so these are basically 10 plus 10, 20. So the total number of cards are 20. So initially, now again considering the 20 slots here, okay, so these are basically the slots. I'm writing it like this because the number of slots are greater than the available space with me. So initially he will have 20 choices, then 19, then 18, then 17, and at the end he will have the last choice. So as it is the combinatorial problem, so multiplying them together I will get the same numbers here, and this will be the 20 factorial number of choices in which he can arrange 10 red and 10 black cards, okay, which are numbered from 1 to 10. This is the answer of the first part. Similarly, in the second part, suppose we draw the cards at random and lay them in a row. Okay, so what is the probability that the red and the black cards alternate? So this is somehow a trickier question in which we have to see the concept behind it. So again, let me have this slot here. So the number of slots here are again 20. So 20 number of slots are available here, in which initially if I consider the 10 red balls and 10 red cards and 10 black cards. So if the first card here is the red one, so the second one should be the black one, the third one should be the red, the fourth one should be the black one, and so on. So initially the choices for the red will be 10. Okay, so after it I have to put here the black one, so the choices here for the black are again 10. Again, now as one of the 10 red cards is placed here, so in the third place I have now 9 choices for the red card, and for the black card here I have the 9 choices as well. So at the end what I will get? I will get the choices like 10 into 10 into 9 into 9 up to 1 into 1. Okay, so how it would be? It will be 10 factorial multiplied by 10 factorial or 10 factorial square. So this is basically the choices for the initially red and then black as well. So there is also another possibility that I can also have the black card at the first as the first card, and then the red one, and then red, and then black, then red one. So initially I will have here the black one. So that is another possibility. For that possibility again I have the same combinations and the same possible number of outcomes here. So I will get here 10 factorial whole square here again. So that is again another possibility. So in order to copy it here, let me move down here. These are basically the 10 factorial, this one. So the choices I will have will be either, let me move it, either the first red choices or the first black choices. So these are basically the two choices, and any one of those will be here, can be here, which is the possible outcome. So tackle the questions where or is concerned, or one of the two will be the correct one. I can use the plus sign here, and that is basically used to denote the or operation. Okay, so here for the first red choices, how many combinations will I have? I will have 10 factorial whole square. And similarly for the first black I will have 10 factorial whole square as well, and here it will be 10 factorial whole square. Okay, so that is the choice when the red and black will alternate with each other. And the total number of choices I have is how much? So the total number of choices I have is basically 20 factorial. Okay, so now in order to find the probability of the alternating cards, what will happen? I have to write here the number of choices when I will have the alternating cards divided by the total number of choices which I have. So that is the answer of this question, where when I have the alternating number of red and black cards. Okay, so that is the solution of my problem. So because of the limited space, I basically move down here, but the choices or the question here as well the same one. So that's it for today, in which I have discussed many questions which are related to the probability and random variable, and with some more questions I will get back very soon. Till then, take care of yourself and I will see you very soon. Thank you.